Okay, so in last session we have seen decision tree model, and the accuracy that we got from the decision tree model is somewhere around 87%. Now let's build one more model from tree family only, and then compare the two models, and we'll select the one model which is giving highest accuracy. So decision tree is a tree based algorithm. Now the second model that we are going to build is a random forest. That is also again tree based algorithm, but random forest is much more better than decision tree model. So that's why I have picked random forest model. Okay. So let's implement the random forest algorithm. So the first thing you need to do is import the random forest classifier from Scikit-learn.ensemble. So decision tree is a tree based algorithm. Random forest is also tree based algorithm. But in random forest, we use multiple decision tree. So it's kind of an ensemble learning. That is why we need to import the random forest classifier from Ensemble. So decision tree algorithm works only one time, but inside the random forest algorithm, we are going to use n number of decision tree. So first we need to import, and then we need to create an object of the random forest classifier. So random forest classifier, when we create an object, we need to pass the parameter also. We can start with default values like n estimator equal to 100. Now the meaning of this n estimator means how many decision tree we need to train. So what random forest classifier does in the background, whatever data we have, it will create a bags of that particular data. So let's say here we are using 100 n estimator. So it will create 100 bags with the same data, and those bags will be created with bagging approach. So it will use bootstrap aggregation, and it will create multiple bags of the same data. Now all the bags will be different from each other. So let's say in bag 1 you will have some random rows and columns, because on each particular bag random forest will train one decision tree algorithm, and at the end it will compile all the prediction from all the tree algorithm. So that's why random forest classifier algorithm called as an ensemble model. So we are going to implement 100 decision tree algorithm inside this random forest classifier. Random state again 42 means we want repeated output. So here we have created an RFC object, means random forest classifier. Now we have implemented the model. Now let's train the model. So again in sklearn, we just need to pass rfc.fit function. Inside the fit function, we will pass extend._scale and ytrain. So let's implement that as well. Now we have trained the model on scale data. Let's calculate the training accuracy. So for training accuracy, we will use rfc.score, and the training accuracy is 93%. If you compare this training accuracy with decision tree, then it is somewhere around same 93.4865. Here it is 93.4865, almost similar. Now let's do the prediction on test data. So now we will pass xtest_scale, and here we will get the prediction value like again 10001. Now let's calculate the confusion matrix. So again in confusion matrix we'll pass ypred and RFC pred data, not equal to true, CMAP equal to blue. So CMAP is basically a color map, means it's a theme. Not equal to true means we need to write that particular number on each square box. Let's calculate the confusion matrix, and this is the one. Now let's calculate the error. So error is nothing but non-diagonal part. So 20, 61, 20, these are the correct prediction, and here error is 2 plus 2, 4. Then this is 1 plus 5, 6, 7, 8. Okay, so total 8 values, and here 4 values. So total we have 12 error, 12 wrongly predicted values. Let's compare this with the decision tree. So here 8, then again 4, 12, 13, 15. So random forest is not able to classify 12 data points correctly, but decision tree is not able to classify 15 data points correctly. So 3 data points are accurately predicted by random forest. So based on confusion matrix, we can conclude that random forest is working little better than decision tree. So let's plot the distribution for both, like random forest as well as decision tree. Sorry, that actual output as well as predicted output. Now here you can see again the decision tree output, the random forest output is following a proper pattern, and the random forest has captured that particular pattern, and the actual value and the predicted value is almost close to each other. But again, for few cases it is not exactly same. So in terms of random forest, it is predicting much better than the decision tree. Okay, so if we compare both, like decision tree and random forest is the clear winner. But let's calculate the classification report as well. So on the classification report part, we just need to pass the y-test value, RFC pred value, and let's calculate the accuracy score on test data. So we got somewhere around 89% accuracy, and again support is same when it comes to the both the decision tree and random forest, because we are using the same sample test data. But when you compare the F1 score of both the algorithm, so here we got 80%, 96%, 82%. But in decision tree, it was somewhere around 79%, 78%. So based on decision tree, based on classification report accuracy score, random forest is the clear winner, and we can see that accuracy is somewhere around 89%. So if we go from decision tree to random forest, our accuracy is increased 2%. So decision tree was giving some 86%, random forest is giving some 89% accuracy. So in both the cases, in both the scenario, random forest is working good. So in one way, what you can do is you can do hyperparameter tuning as well. So let's say instead of using 100, let's try to increase the number to 500. So now we are trying to tune the random forest algorithm. So I have used 500. Let's train the algorithm again and calculate the training accuracy. Again same, let's do the prediction, calculate the confusion matrix. So confusion matrix is again phi 2 same. So we did not improve. Let's calculate confusion matrix again, classification same. So instead of 100, even if we go for 500, the accuracy of random forest did not increase. Let's go for 1000. Okay, then again train the algorithm. Now 1000 algorithm will take some time. So we are passing n estimator equal to 1000, means we will train 1000 decision tree in the background. Let's calculate the training score. Again is approximate same. Let's calculate the prediction value and confusion matrix. So 2 again almost same. Let's check the classification report. Again same. So even if we are tuning the random forest algorithm from 100 to 1000, we are not getting good accuracy. So this is the limit for the random forest algorithm. So instead of keeping the random forest n estimator parameter to 1000, keep it very low, like 100, because anyway we are getting a very good accuracy on 100. So even if we increase from 100 to 200, 500, we are not getting good result, but the model complexity is getting increased. So always stick to low number with high accuracy. So 100 is a optimized value for random forest. So in conclusion, if you compare random forest and decision tree, random forest giving a good result compared to decision tree. Now, whatever the conclusions you have, you can write that for the entire project. So from the exploratory data analysis, we have concluded that sleep disorder depends on the three main factors: gender, occupation, and BMI of the patient. Male patient has more instance of insomnia, whereas female patient has more instance of sleep apnea. In addition to, the people with occupations such as nurses are more prone to sleep disorder, and the BMI of the patient also plays a vital role in sleep disorder. So the patient who are either obese or overweight are more prone to sleep disorder. And coming to the classification model, so both the model perform pretty good, but random forest classifier have an excellent result of 89% accuracy. So this is the conclusion of the entire project. So we started with a data pre-processing, data reading, feature selection, EDA. After EDA, we did the data pre-processing again. Then we did data splitting, and then we built two models, random forest and decision tree. Then we calculated the confusion matrix accuracy score, and we compare the performance of the two model. And based on that, we concluded that the random forest is giving a clear accuracy, good accuracy. Now the next step is we have built the entire machine learning project on Jupyter Notebook using a proper Jupyter kernel and Anaconda environment. But we cannot able to deploy this Jupyter Notebook onto the production environment. So for that, we need to convert all the codes into a proper .py file. But the goal of this project is to deploy this project on AWS. So we don't require all the code files which we have written in this Jupyter Notebook. So we will select only those code which are used for the deployment part. So next step is create an inference pipeline and then convert all the code into a proper executable format using .py file. And then we will create API, and after creating an API, we will deploy that particular project on local, and after that we will deploy this project on the cloud environment.